All right, so we're going to talk about how much dispersion can affect hit probability at long distance, and this is a handy tool. This is the Joint Marksmanship Assessment Package using our AI scoring feature. So this is a 10-round group that I fired with 77 grain Black Hills from a supported position. So 10-round group, it recognized the shot holes, recognized that this was fired at 100 meters because this is our standard 100-meter target. Already filled in, group size in inches was 1.48. And you can see at 300 yards, that red circle indicates that group multiplied by 3 inside of a 12 by 25-inch C-zone target. So the standard target for this assessment at 300. Now, the cool thing is we can also play with distances here. So we're going to switch it to meters because meters is what we're actually doing everything in. And so we're going to go ahead and see what that hit probability does. If we double the distance, we go out to 600 meters. Notwithstanding wind or ability to correct for drop or any standard deviation muzzle velocity, this is just assuming best case scenario, raw precision of the rifle, we still have 0% misses at 600 meters. That's using a 10-shot group. Now let's see how much that changes if I use a 30-shot group. And this is the same ammo 30-round composite group, ends up being 2.37 inches. Here's that group. You can see still pretty tight, a lot of holes in there. 2.37 inches. Expanding it out, getting more information, we can see we're actually up to a 10% built-in miss at 600 meters with this ammunition. Or how far can I back this up before I get to 0 built-in miss? If I go to 550 meters, 3% built-in miss. And at 500 meters, we're pretty much at 0.02% built-in miss, or it lines up. And what happens if I'm using worse ammunition? Oh, I'm sorry, this is much better ammunition. This is worse ammunition. That's 30 rounds of 4.42 inches, 30 shot composite group. This is just, not very good ammo. And at 500 meters, we're sitting at a 43.95% built-in miss. Again, that's just precision, not factoring in muzzle velocity, standard deviation, just precision. So in order to get to 0 built-in miss, so make that circle fit fully inside of that target, we got to back it up to about 200 meters, 250 meters. We're at 0 built-in miss, so if that's all we got to do, not too bad. 300 meters, 4%, so we're no longer 100% guaranteed just mechanically. So 250 meters is our max effective where we know we can get a hit inside of the C-zone plate using that ammunition. Or I go to something much better. These are 69 grain hand loads, and that 30 shot group comes in at 1.76 inches. And so 0 built-in miss at 250 meters and plenty of slop. That circle fits in there multiple times. So, if I have my dot off to the right side, left side, doesn't really matter. But if I change that distance to 700 meters, now we're getting to be just a bit outside, 1.66% built-in miss on that C-zone target.